Now let's look at this question 2E from paper 2011. We want to explain why if a photon causes an electron to jump to a higher energy level, the exact energy of photon is critical, but it is used to release an electron from the atom. It is only the minimum energy of the photon that is critical. So I think this question still contains like two parts. No, this is part 1 and this is part 2. We want to explain why the exact energy of a photon is critical if I want to achieve something like this. And part 2 is why the minimum energy is critical if I want to achieve this. Like if I want to release a photon from an atom, kind of like photoelectric effect. If I want to see that, why the minimum energy of a photon is critical. Now let's look at the first part. Photon causes an electron to jump to a higher energy level, and it has all the things to do with atom. The first part is about atoms model, and in class we focus on both model of atoms. Okay, and number 2 has everything to do with PE effect, photoelectric effect here. Both of the topics are covered in chapter 11. Okay, now let's look at the first one. Still, maybe when explaining this, we want to use hydrogen atom as an example because it is the simplest. Now this is a proton, and this is the shell. Now remember that this shell I'm drawing are like actually the quantum energy levels of electrons. Okay, yeah. Now, jump to a higher energy level. Okay, great. Now, let's say that, the single electron is here. It is at level 1. Level 1 contains energy level, and this is level 2 and level 3, and going up we have level 4, level 5, okay, right? Now, all of these energy levels should have a negative value. We have already covered it, right? Yeah, because we know that, in fact, an electron should have this positive negative energy. But we are talking about the difference here. Let's look at level 1 and 3. Level 1 and level 2. The difference. I'm talking about the difference between level 1 and level 2. Level 2. If I know that, okay, let's use some examples here because we know that for hydrogen atoms, level 1 is a constant number, is a fixed number, and level 2 has this constant value of energy 2, and level 3, level 4, level 5. But we are using examples here, okay? Yeah, we want to simplify this. The difference between level 1 and 2 is, let's say it is equal to 10 eV, 10 eV. So if, originally this atom is on this ground level, level 1 here, okay? Now if this is like spinning here, okay? It's like revolving, okay, around this proton. And if it receives this energy of 10 eV, it should immediately jump to level 2, okay? If receive this energy, this 10 eV energy, value of energy, it jumps up to level 2. How about it receives like 9.995 electrovolts value of energy? It can't do it. It doesn't do that. It must receive that exact value. How about I give it like 10.5 evolts. Let's say that the difference between level 1 and 3 is actually 11 evolts. This is level 1 and this is level 3. That's 11 evolts. So if it receives like 10.5 electrovolts, can it jump to level 2? No, it can't. It can't, because for level 2 I only need like 10 evolts. Now, can I jump to level 3? No, I can't. Sorry, it can't. The electron cannot, because it needs this amount of energy. Okay, so the exact value is the most important thing. So maybe we want to write something like this. Yeah, let's erase this. Wait, how come it's really hard to erase all things? Yeah, maybe because my computer is very slow at this moment. I don't know why. I think it doesn't like me at this point. I don't know why. All right, okay. So let's write something like the exact energy of the photon is of critical. We can say for an electron to jump jump to a higher energy level, it must receive the exact value of difference of the two levels, no more and no less. Because of quantized energy transitions, we can say something like this. Okay, for the second part, if it is used to release an electron from the atom, actually we're talking about now a photon can release some of the electrons from some atom. So actually this is a photoelectric effect, right? So for the second part we can say for photons to release electrons from an atom, it only needs to overcome the work function of that metal. We're talking about this. Ek is going to be equal to E photon minus phi. We only have to make sure that this part, we only have to make sure that E photon minus phi is greater than 0 or equal to 0. It should be greater than 0. All right. So this minimum energy, so E photon has to achieve a minimum value to exceed that. Let's move down a little bit, okay? To exceed that work function to eject or to release electrons, which is the photoelectric effect. Yeah, and we're done here.